Hello and welcome everyone. Thank you for joining us today for our webinar titled Actionable Strategies for Mitigating Risk and Driving Adoption with Responsible Machine Learning. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Ben Cox is the Director of Product Marketing for H2O.ai. Navdeep Gill is a Lead Data Scientist at H2O.ai. And Patrick Hall is an Advisory Consultant at H2O.ai. Now, before I hand it over to the speakers, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Patrick.
Hey, can everybody hear me? Hey, Patrick,
yes, we can hear you.
I'm just making sure. Okay. Yeah, so great, and thanks for joining us to talk about this lively and important topic. So it'll be myself and Ben Cox and Navdeep Gill, and we're all three authors of a recent report. You know, the main point of this webinar is to sort of give you a summary of the report and give you a link to the report at the end. So, you know, you don't have to take notes. Everything that we're going to be talking about is sort of written down in a nice report format that we'll show you at the end. So keep that in mind. And we can probably just go to the first slide, Ben. So, as you know, we introduced the webinar. You heard this idea that we wanted to give actionable guidance on responsible machine learning, and so why actionable? So what you're seeing on the slide is a report from a group known as Algorithm Watch in the EU. That there's lots of interesting people to follow in this space, and Algorithm Watch is definitely one of them. And they recently did a report on the effectiveness of different organizations' AI principles. So probably some of you on the line, you know, this concept of responsible AI or responsible machine learning may be a little bit new, and we'll talk about what that is very shortly. But for others of you on the line, it's probably something you've been thinking about for you know, months or years, if not your whole career. And so something that's kind of been a trend recently, and I do think it's a very good idea, is to have sort of guiding AI principles for your organization. And Algorithm Watch actually keeps a inventory of these kinds of principles. And so, like, if you were wanting to do this for your organization, I'd urge you to go to Algorithm Watch and look through their inventory of AI principles and see how many other companies have done this and what they're doing. But the one thing to watch out for is it's really sort of broad, nice-sounding statements about AI or machine learning that just aren't actionable. They're just not implementable at the practitioner level. So what Ben, Navdeep, and myself tried to do is make a report that would be very direct and very practical for you know, both sort of decision makers and hands-on AI practitioners. And you know, you'll be the judge at whether we see it or not. But you know, the intent is not to just give high-level sort of speculation about AI and machine learning, but to give real practical hands to the keyboard advice on how to do this. And
yeah,
another reason,
Patrick.
go ahead.
Yeah, so I was just going to say, like, one of the things that happens is, especially with artificial intelligence, like there's this big rush to kind of adopt it, but then you start to think about, you know, with software, you go through all of these rigorous testing phases. And so a lot of times with these papers, it gives you some principles and like good, you know, themes and design frameworks of how to start to consider, you know, AI as a concept or AI as a technology. But I know personally from a consultative background, naturally the company is just going to ask, okay, but like, how do I do it, right? So there's just, we realize this big disparity or discrepancy between hyper-technical research saying, this is the new leading algorithmic method, and your AI should be benevolent or your AI should be kind, right? So we try to do a fastball down the middle, essentially say, look, companies are adopting this, but there's not a clear roadmap on how to do it from a people, process, and technology perspective that they care deeply about, right? So.
Yeah, exactly. And I'm sorry if my audio is choppy. I'll try to work with other Patrick to see. But all that Ben's comments were right on, and all that I will add is that now is the time, right? Like AI and machine learning systems are failing. Anything from kind of funny or embarrassing for companies to millions of people being discriminated against to people dying. So, now is the time to start taking action on this topic. Get the report now. So we can go on to the next slide, or Ben and Navdeep, feel free to.
Yeah, I would just piggyback on that and say, we're at this really good point in time. We actually be kind of past it, but we had this really long period where companies were sort of given free reign to build AI systems and not really have to report to anybody about it or, respond to oversight authorities, and that's really changed, right? And the thing is it's not just, oh, well, when a regulator calls you, can you explain things? But it's a matter of, machine learning technical debt, right? How much is it going to take to unwind all of your machine learning practices should they not, be up to snuff, right? And certain countries have different layers of review and oversight, but if you're a company adopting these things in production, you have the opportunity to get out in front of it now, and it doesn't take that much, right? We're trying to assert also that it's very doable. It's not something that, wait till it breaks and then try to, put Scotch tape over it. We kind of assert that there is a way to go about this, and whether it's, ubiquitous or all-encompassing of fixing everything is a whole other question, but there's some very material decisions you can make right now and affect a lot of positive change for your data science, business unit.
Yeah. And again, I think Ben is teeing up one major component of what is responsible AI or what is responsible machine learning, and definitely part of it is compliance and legality, and that may seem a little strange to us in the United States, but just on Tuesday, the good people of California passed a law that basically says, in general, that machine learning systems need to be transparent, that people need to be able to opt out of automated decision making, and then it adds to the categories of data that would be considered sensitive that were already described in the CCPA. And this is in addition to just a wide-ranging number of federal and local attempts to regulate this powerful technology. So on the slide, we're talking about what is responsible machine learning and what is responsible AI. I don't think we really know yet, but these two diagrams on the graph seem to be, on the slide, seem to be decent definitions. I think it'd be great for Ben to kind of talk through his definition a little bit more, and then maybe Navdeep and I can talk through the responsible machine learning definition on the left.
Yeah, sure. So I know I just kind of painted with a broad brush and said your AI should be explainable, your AI should be compliant, are kind of these platitudes of nothing that can tend to occur. But what I'm trying to with this image on the right, we're trying to focus in on is the domains that matter here, right? Each of these, we provided definitions for, we describe what it means to us, and again, we don't write the dictionary, but only the industry will at the end of the day. But it's kind of an ongoing learning process, figuring out what is best practices, right? So we kind of assert these 6 themes, explainable AI being, can you do post hoc analysis on models and understand why the decisions that the model made, why it did what it did? Human-centered machine learning, and that, having humans in the loop, getting humans in the loop, and not trying to create these fully systematic artificial general intelligence, recurrent deep neural nets when you can just use models with the loop, humans in the loop. Compliance is exactly as Patrick just discussed, but, what you'll hear a lot too is ethical AI, and that one is a little more broad because the definition of ethics and fairness is a whole other thing. But you should know if your machine learning systems are discriminating against or creating a disparate impact for one, class or category of a feature, versus another, right? Some of this makes it into law. Some of it is just, as a company operator, you should know this, right? And secure AI being, somehow we ended up in this world where machine learning skipped all of traditional, software testing, and, AI models can be hacked, right? Are you aware of that within your organization? Do you know how you even begin unwinding that or creating more dynamic, robust, resilient models? And then interpretable machine learning, like, given the choice, can you choose a more transparent model architecture versus a deep neural net with 30 hidden layers, right? Can you lean into the transparent model architectures or create more transparency in typically black box model architectures? So those are the kind of 6 themes, but obviously, they're not definitions without, some kind of proposal of, here's how you need to start thinking about this. And that kind of gets into the image on the left, which Patrick and now Deep can talk to, because that's kind of the workflow where you start to tackle some of these domains.
Yeah, so the workflow on the left is what we mean by sort of practical advice, like really more detailed steps that practitioners could take. And I think that the machine learning practitioners on the phone can read the slide, but hey, Navdeep, maybe if you drew some parts of that workflow that really have stood out in your own work.
Yeah, sure. Yeah, so, in a past life, I've worked as a data scientist as well, and, this sort of workflow is, I think is expected. I mean, most of this stuff is what people do anyway, so exploratory data analysis, feature engineering, things like that. There's some stuff in between that maybe people don't think about too much, so, interpretable features. It all depends on your application, but a lot of times I feel you need to strive for these type of things. Things like, on the bottom there you see human appeal of model decisions. And I think every data scientist might go through this when you have to present your results to someone like upper management or anything like that. Also explanations kind of goes into it as well. And human review and documentation has been a big part of what I've been involved with. A lot of times after building a model or anything like that, you have to document it heavily so people in the organization understand what you did, and you kind of give them a sense of security in what you're doing as well, because if they understand what you did, they're more comfortable with deploying this type of machine learning model. So there are bits and pieces that you're probably already doing in this flow chart. The main takeaway I would think is, as a whole, all these steps should be, very important to you, and all these steps should be taken in sort of your machine learning or data science endeavor for whatever problem you're trying to solve. And solving or using this type of flow puts you, I think, in a position of success. It puts you in a position where if you need to answer questions about your model, you can answer those questions. If you need to ensure that your model cannot be hacked when it's deployed, or your model won't be affected by data drift. So, for example, right now we have the COVID situation, so there might be a lot of drift going on for machine learning models out there. However, if you put your system or your ML system in a position to kind of catch this, and you have some potential solutions to take care of this, that's a very good thing. And that's a very good thing for your organization. That's a very good thing for you or your team members. So this is what I think this overall flow is doing. It's putting you in a position of success. It's covering all things you should look out for. And, that's my opinion on this flow. And I heavily believe that, this is what data scientists and analysts and anything, tech leads, all these type of people should be striving for, for anything that they do when it comes to data science.
Great. Hey, Ben, you want to move on to the next slide? Or whoever's driving here?
I'll move on, but I'll make one more point here. What I think a larger idea here is we're presenting a workflow, right? But what, as a practitioner who probably, has spent a lot of time in various tools, right, you as an adopter should be looking for the technology opportunities to cover as much of this workflow as possible, right? Like we designed the machine learning interpretability and explainability toolkit at H2O around this theme, right? We want to be able to create an end-to-end system that actually contains these steps, right? Because a lot of things, if you're just operating in a Jupyter notebook and you're just, pulling in libraries, you're not going through these processes. So you need to be, looking for the technologies that can enable and kind of accelerate this workflow in a positive fashion. All right, so. Yeah, I guess I can kind of, continue on here, right? I made a comment earlier about getting in a loop and human-centric machine learning. The critical point is that when AI kind of really adopted, it got really exciting because it was this concept of, ooh, it's perfectly scalable, we can give these machines agency, we can have a fully autonomous workflow. And my first job was in quantitative finance, which is fully systematic trading system. But the reality of a lot of machine learning now is your goal shouldn't be to take as many humans out of the loop. It should just be, it can be using AI and machine learning to distill a large amount of information or uncover more information and provide that to humans, right? There's this whole augmentation versus automation concept. And I'm a very big advocate that, when you start to go into your, machine learning adoption curve, it shouldn't be how many people can we remove from this workflow. It should be where can we use machine learning to give our existing team the best insights possible, right? And there's this human-machine trade-off that some tasks are more redundant or rote and, require less human intervention, and you can kind of sort of start outsourcing some of those to more, predictive systems. But a lot of the value and use cases that I see in the industry are people, looking to just give their analysts, their associates, their decision makers, the heavy artillery of insight, right? So I think that this gets kind of mistaken a lot, where it shouldn't be about removing people. And I think it was either Deloitte or Accenture did a study about what are the use cases that are most common for machine learning adoption and which are the most successful. And it's the ones where you're looking to augment an existing team with deeper analytical insights that perform the best in industry, right? That's where you see the most value being created from machine learning and AI. And it's where everyone should start, right? Because until you start fully knowing, at the end how well these models perform out of sample and in production, you should very much just have it as an augmentation tool to make your data scientists better, to make your analysts or decision makers better. So, Patrick, if you want to piggyback on that.
So I tried to change my audio. Can you guys hear me better now?
Yeah.
Yeah.
I think.
Okay. All right. Yeah. I mean, I think there's just a ton on the slide to talk about, and we could probably spend the whole hour on it. I'll just try to call out something that is really important to me, and I think it's this user appeal idea that Navdeep already hit on, and I see so many problems with machine learning systems, or really even algorithmic decision-making systems, where the outcome of the system is presented to the end user as sort of this like irrefutable voice of God. And that's a really stupid way to use machine learning, because machine learning is often wrong, right? All models are wrong, some models are useful. And you're dealing with this technology where wrong decisions are a feature, not a bug. And so you really need people to be able to, you need to deal with that reality of making wrong decisions and allow your consumers to help you out there. And I think like that would prevent a lot of lawsuits, that would prevent a lot of heartache. And so just technically thinking through how you're going to enable people to interact with your system, how you're going to enable consumers to interact with your system is a really big deal here. Navdeep, I'd love to hear your thoughts on, like a more diverse team of people being involved in AI. And I mean that like both demographically, but also just different kinds of professions. So I know you have different kinds of science in your background. And would love to hear any of your thoughts there.
So just to be sure, you made any thoughts on, the user appeal aspect and operator override of these type of things?
Just in general, have you, are there things that you learned from, your experiences in neuroscience that have helped you in machine learning? Are there things that you see, not being a white dude like me, that you see in machine learning?
Yeah, I think, one of the issues that a lot of people have faced, especially since on the slide we have facial recognition, so that was a big thing that people deployed, deployed on people, obviously, and, led to a lot of issues. A lot of issues were, lack of demographic information. This type of thing was featured in a recent documentary called Coded Bias, where they sort of went over the facial recognition that was deployed by different companies. And, the main thing that it sort of posed was that a lot of this technology is not really regulated. It is regulated to a certain degree. Now, at least facial recognition was taken up to Congress and then, was eventually removed from a lot of different applications. But yeah, from a demographic standpoint, yeah, I don't think we have the diversity needed to sort of use this type of technology quite yet. And you can tell that just based off of the facial recognition studies that have been done, sort of, it's always the same thing, the white males, they tended to do well in these type of systems when there's a classified versus, pretty much everyone else. So this type of, user appeal, deploying this on people is a very complicated thing, and, there's more risk, in my opinion, than there is reward. And we've seen that. And it's the same concept if you're deploying models to get people credit or home loans or anything like that. There's a lot more information that is required to sort of understand this. So one example I want to give is, if you come from not really affluent, but you come from a family that's maybe middle class or upper middle class, I think more likely than not, it will help you buy a home. Maybe not all the time, but they might help you. Your parents might help you, grandparents, whatever. Now, if you come from a poorer background, you don't really have that opportunity. So then how do you give these people an opportunity to get a home? Or do you give them a lifetime where they can't be homeowners? So this is something to consider when you're building out these models. So this is a direct application to people today, in the past. So, those are the type of things I think about in sort of these data science applications. So the facial recognition aspect is, go ahead.
Oh, I was just going to say, Navdeep, myself, and Patrick have all worked to take a crack at this from various ways, like trying to do some writing that, defines fairness, or thinking about what kind of algorithmic bias tools can, or bias audit tools can be enhanced. The reality is that it's very easy as a person with the ability and access to data science to get a data set, fire up a model in less than 10 minutes and say, oop, there's signal, let me use this model. But when you keep domain experts out, you don't have the industrial knowledge to know, oh, well, there was a period in time where things were handled very differently, and that's impacting the bottom line of the model as it is today. And then there's this other aspect of, not even domain experts, but outside domain experts, where I think we comment in the book that some of the, most successful famous companies, like Renaissance Technologies or McKinsey, are very big on hiring experts in fields that don't seem to matter to whatever problems that they're trying to solve, because having these outside views creates some, an environment where you can challenge the thought process, and it's not, data scientists just seeing a signal and immediately going with it. It's asking the critical questions about, did we design this experiment in a way that can actually give us unbiased results, right?
Yeah, I agree. I think, yeah.
No, go ahead, Navi.
Oh, no, I was just going to say that, looking at these things like machine learning models that are sort of biased, built out to be, there's not much diversity in the thought process. I think that sort of comes down to the fact that, a lot of you have to look at the diversity of researchers putting this type of thing together. The more diversity we have, the more questions that might be posed from different viewpoints.
Yes. That's so important.
If that happens, these machine learning applications I mean, maybe not 100%, but a big percentage will become diverse in their applications. A lot more things will be thought about, maybe carefully thought about. Just more opinions going around across the room will help make these machine learning systems a lot more safer. It would help a lot of people if we can achieve this.
Yeah, agree. I just want to, there's an audience question about the slide that I wanted to address, but maybe before we move on to the next slide. So thank you both for those comments. And I thought, both shows like, where you guys have been working and where you've come from, and so I appreciated that. But there's a question from the audience about going nuclear, and so I want to be clear. That was just kind of a catchy phrase we used. So I think people, what we mean when we say going nuclear is sometimes what organizations do with machine learning is so objectionable that you would do something like protest or join a protest. There have been instances of people doing white hat hacking to expose flaws in machine learning systems, and then of course there are data journalists who are completely focused on kind of uncovering unscrupulous uses of machine learning. And in fact, the New York Times opened a new sort of website just for this purpose, and there have been employees at big companies who have exposed internal things to this website. So that's what we mean by going nuclear, is that sometimes things are so bad you have to take a risk, and that obviously that's a person-to-person decision, but that's what we meant by going nuclear. So like I said, we could talk about the slide for an hour, but maybe we better move on, unless anybody else has some finishing comments there. All right, so I'll tee us up on this slide. I think, and again, echo something that Ben said earlier. I'm really tired of exceptions for quote-unquote rockstar data scientists and machine learning engineers. These are security problems. They're software quality problems. And so I think a question that Ben and Navdeep and myself end up asking a lot is, machine learning is almost exclusively software. I can't really think of a machine learning system that would not be software in 2020. And so why aren't machine learning systems and the people who design them subject to the exact same processes and sort of software quality assurance that goes into regular software? And so I think a major thing when you're thinking about machine learning processes inside your organization is there's absolutely no reason to be making exceptions for data scientists and machine learning, right? They're just making software. That software should go through whatever software quality processes your organization is already doing. The security processes should apply to data scientists and machine learning engineers. And then moreover, there's more work to do because machine learning systems are more complicated. And so, you can maybe hear from my voice that this is a little bit personal to me, and my thought here is really like, yeah, this is a lot of work, but with a lot of, with great power comes great responsibility. And many data scientists are paid more than general, practitioner physicians. So if you're telling me if you're making more money than a general practicing physician, you can't think about the risk of your work, give me a break. But so I'll tee that up for Ben and Navdeep to jump in, and interested to hear what they have to say.
Yeah, I'll jump in. We kind of get on this next slide here, Tame the Wild West of machine learning processes, right, or processes. We showed our proposed responsible machine learning workflow, and we really do believe that that's, it's not a finished product, but it's definitely a great place to start to put some guide rails around how does this work. Because I think what happened was everyone got so excited about machine learning adoption that there was no structure of how models are built, how they're tested, how they're put into production. Every company kind of went about it on their own, and there's no, Agile and Scrum are very well accepted across industries for software development lifecycle, right? But there wasn't that for machine learning, and the problem is yes, it doesn't mean that something's going to go wrong or they're going to, create some big moral hazard with models. But what we do propose is that you can create a linear workflow that checks for all of the major red flags and covers your basis for all of the major regulatory or oversight potential, downstream risks, right? And the reality is, and something I want to clarify here because I don't think I sell this enough, right? The result of creating a responsible machine learning workflow is not just some defensive, oh, I've got my back covered for a regulator, but when you do this and take a very serious look at how you go about building models, you're driving a ton of value. You're creating models that are more stable, that won't break in not as anomalous as you thought situations. You're creating a lot of post hoc data from your explainability processes like Shapley values, surrogate decision trees, rule-based systems. You're creating all of this insight, so you get this like very nice machine learning metadata that you can really understand where your models are at and get a real better picture of how it's actually going to perform once you put it into production. So it's not just a defense mechanism, right? It's creating an organized structure that creates a lot more value from your models and gives you a lot more insight to your end customer or your end clientele, right? There's value to be driven from a good process here, right?
Yeah, and I would just say from my perspective, for large organizations that are already sort of operating under a regulatory compliance burden, responsible machine learning is just a pure win-win. I don't have much data to back that statement up, except for my own sort of personal experience. But for smaller organizations, slowing down can oftentimes be a problem. And I think for those smaller organizations, one of the key things that you can do is what's known as an AI incident response plan. Okay, so you don't have the people and money to set up 3 lines of defense like they would at a major financial services firm. But what you can do is try to think through how your machine learning system could fail and then document how you would respond in those cases and make sure that you have budget to respond, make sure that you have people to respond, make sure that you have what you need to respond in case your machine learning system fails. And that can keep, like a glitch from spinning out of control into something that ends up in the news or it gets you in big trouble. So, I want to piggyback off Ben's comment. Ben's comment for larger organizations that are dealing with compliance, responsible AI is just a win-win, in my opinion. For smaller organizations, it can be more difficult, and I think for them, instant response planning is kind of the best thing for their buck.
Yeah,
and I'm happy. Go ahead.
Yeah, so I'll add one more bullet, right? Like, as I mentioned, I started in finance, right? And the reality is if the Fed or CFPB comes in and says, hey, look, we're adding this new rule to financial advisors and how they engage with customers, it'll go into effect a year from now. All of these big banks will go invest $100 million or more to make sure that their business is set up for when that cutover occurs. So they're not waiting for an incident to happen, right? They're prepping it so that they can have business continuity, right? So if you're a company that's adopting machine learning, you should understand that, should somebody come in and say, hey, you're really doing this in a haphazard way, do you have the ability to immediately pivot and make good on your machine learning systems, or are you creating a continuity risk where you have to shut everything down? And then do you know the materiality, the volume, the velocity of the actual value of those predictions, right? Some companies do, refreshes of machine learning models and they make, 100 predictions a year. There's models that make hundreds of thousands of predictions a day, right? So some of those systems really can't, you can't afford for them to go offline. So in the case that somebody comes in and says, hey, you really have no rhyme or reason to understand what's going on here, are you able to shut down? So it's about getting out ahead of this and just creating a better workflow so that you're ready for whatever happens, right? And that doesn't even need to be regulatory. It's just your model starts to suck.
So lots of comments, and I want to make sure that Steve has a chance to chime in on the slide if he wants, but I see 2 questions from the audience that I want to get to, and then I want to talk about what's on the slide. So maybe there's an easy question from an audience that I'll address first, which is the slides will probably be available, but I think what you really are going to want is the booklet, which is available for free, and we'll show the link at the end. But I mean, you can also just Google it. It's responsible machine learning, and H2O would probably pull it out. So yes, the slides will probably be available, but everything from the slides is just pulled from the report. What you're seeing on this slide in particular is is a note from the Federal Trade Commission. And just as a reminder, this is the organization that fined Facebook $5 billion in 2019 for data privacy violations. And this note is essentially saying, you know, hey, we're interested in what you're doing with AI. And while they said they're mostly interested in applications in sort of healthcare and financial services, they certainly did not say they were interested in any specific vertical. So you should check out this note from the FTC. It's very sort of representative of what U.S. government agencies are thinking. I think it's very likely in the next few years that like this idea of, oh, AI is just regulated in financial services, or oh, AI is just regulated in healthcare, that's going to go away. And so part of responsible AI is preparing for that. And again, I want to emphasize, like, I'm pretty sure, like Navdeep is in California right now, and in California, there was a referendum, I believe, that just passed that said machine learning systems should be transparent and people should be able to opt out of them. So that's regulation, and people voted for that on Tuesday. There's a note from an audience member that I think worth bringing up that you know, makes several different points. There's a difference between doing ethics and acting ethical. I think to be clear, I don't think any of the presenters here consider ourselves ethicists. We're really just practitioners who are struggling to do the right thing, and hopefully that's ethical. But I don't think we intentionally stayed away from that word because we're just not qualified ethicists. I would say the next sort of point is that modelers and data scientists are focused on feature level and performance concerns and not project level concerns. 100% agree. And a huge part of responsible AI is sort of opening the discussion up to people, processes, and technology, right? To things outside of just technological concerns. So fully agree there. And yeah, and also they're pointing out this, and it's been published on this idea that AI systems are being more and more concentrated in just a few large organizations, and that's a serious concern. And I think one thing H2O talks about a lot is at least the democratization of AI. So I don't know, Ben, if you want to turn in there, or if Navdeep wants to. I've been talking a lot. Sorry.
Yeah, I mean, I can piggyback off of that, right? Like, our motto at H2O is democratize AI, right? We invest a ton of time and effort into creating one of the best. Like, I'm sure most of the people on this call have used, you know, H2O open source, right? And I think it's really, really important because I think McKinsey did a study last year that, you know, the early successful AI adopters will see, you know, 30% annual upticks in value from their investments, whereas the laggards will start to really fall behind for not having access to this kind of like elite technology. I don't know if the numbers will hold or if that's true, or it will turn out to be true, but you know, it's not hard to see that if successful AI gets concentrated in a few core pockets, it's going to create a really wide divide between, you know, the haves and the have-nots. So, you know, I know H2O spent a ton of time in the open source world. We spent a ton of time with nonprofits in the community to enable people to kind of get into AI if they maybe wouldn't have had access to it before, and that's something that we take super serious.
And the final comment on, you know, from that audience member is just because you can does not mean that you should. And I think that, you know, everybody on the line would agree with that statement. I don't know if all machine learning practitioners would agree with that statement, but you know, I think that these are exactly the kind of things that practitioners need to start thinking through. And I'm hopeful that very soon it's not going to be an ethical question, it's just going to be a compliance question. And I hope to God that's the case, and that's just going to be, I think that's going to be better for everybody. It's not going to be, and I think another thing is, you know, what do we expect from data scientists? Are we expecting too much from data scientists? And again, this is why those multidisciplinary teams are so important, so that you can have legal, compliance, insight while you're designing machine learning systems, and ethical insight if at all possible. So thanks for changing the slide, Ben, and giving me a cue to shut up. I'd love to hear Navdeep chime in on reproducibility. I thought, you know, Navdeep is probably the most hands-on machine learning engineer on the call, and he had some really good thoughts in the report about reproducibility, which is like, if you're not reproducible, then you're not doing science, in my opinion anyway, right? Like, science is reproducible. So super important building block for being responsible with technology is reproducibility. And Navdeep, you know how to do it, so tell us how to do it.
Yeah, sure. So yeah, like you said, reproducibility is very important in science. The common thing, I used to work in neuroscience a lot, so the common thing is if you put a study out there and no one can reproduce it, well, your reputation has been sort of brought down a little bit. So that's one thing to consider as well in the machine learning application is you sort of want to be able to reproduce the models that you're building. If you need to, debug later on or check something after a model's in production, you want to be sure that what you're looking at is what you built. So one of the few things you can do with that is, you can keep track of some type of metadata that you have about your model to understand, what was the inputs, what was the pre-processing, how was the model built in terms of parameters, what was the validation like, who signed off on this model, any type of deployment details, like where was it deployed, what type of environment, things like that. So, having this type of information will allow you to sort of avoid any issues down the road, if any should arise. One common thing you'll see in machine learning libraries is, sort of this idea of having, random seeds for a reproducible model. I think this is pretty common. I don't think I need to explain this too much, but, when you build a model, just passing the seed argument, and that should be, good enough to keep track of everything if, the machine learning algorithm, is built in a way to keep track of it. So, for example, in H203, all the models take seeds. Things like scikit-learn, TensorFlow, like any machine learning package that's pretty popular will take in a random seed. Other things to consider. So we live in a day now where Git and GitHub is a very common tool that people use across many facets of software. Like Patrick mentioned before, machine learning is, sort of software. It's all built to be like a software package that people can use. So if you're building your own machine learning algorithm, obviously you want to use version control, especially if you're sharing across a team. If you're utilizing certain packages, you want to keep track of the code they're using to use that package and also the versions of the package that you're using. So if you do upgrade and something goes wrong, you know which version to go back to get back to the behavior that you found or you deemed acceptable for your model. Other simple things to consider is sort of the environments. What is it deployed in? Docker, a virtual machine? Is it on-prem with some hardware? Those type of things you want to make sure you understand and you work with the right personnel to sort of understand what they are. Because a lot of times what I have to do is I have to reproduce something. A lot of times I can't reproduce it, let's say, on my own desktop that I have that I use for work, but I need to get into some cloud instance to match what the customer, this other person saw, to reproduce. So this is the same concept as well. You want to make sure that the hardware and the environment is something you can try yourself after the model has been deployed. This is just a better way to debug things and just a better way to avoid wasting your time in the future. And
so I want to key in.
Yeah, go ahead.
I want to key in on the debugging part in just a second. And there's been another audience comment about something I think Ben said that we should probably circle back to. So I'm thinking maybe we'll wrap up the technical discussion here in a minute or two, and then try to turn it over to the audience for more comments and questions. But the way I see this, the sort of technical aspect here is, so reproducibility is fundamental, right? Like if you can't reproduce your results, I don't know what you're doing. So if you can reproduce your results, then you're sort of standing on solid ground. And then I think, above that solid ground, you have three more levels. You have interpretability, which is fundamental also. Like, can you understand what your system is doing and why it's doing it, how it's doing it? Once you have fuller interpretability, then you can have better debugability, right? Again, machine learning is software. It has bugs. It needs to be debugged. And then once you can debug it, then you can be accountable with governance structures, right? So I think like there's three sort of levels where technical plays into model governance, and broadly speaking, it's reproducibility, interpretability, and debugging, which would certainly in many cases include sort of discrimination testing and discrimination remediating. Remediation is a really important part of model debugging. So Navdeep, I don't know if you want to comment on any of that, but if not, then we can turn it over to this comment from the audience. But feel free, Navdeep.
Yeah, the main thing I just wanted to comment on when you're trying to build a machine learning model for some application is the concept of benchmark models. I find those very important. That idea there is, if I'm trying to, let's say, predict if someone should get a loan or not, maybe the first thing I built is maybe a simple decision tree, a GLM, something very simple where you can tell exactly what the model's doing before you go on to something complex. The idea here is, sort of this law of parsimony. You want a simple solution, which is probably better than a complex solution that is not much different than the simple solution. So that's just one thing I wanted to harp on, is just the idea of benchmarking and having simple models first and then building the way up and then comparing back to the simple models and ensuring that that more complex model is actually needed. And that's pretty much what I wanted to add to that.
Yeah, so I'd jump on that too and say, the benchmark models are incredibly important, both for reproducibility, right? You have benchmarks that you can get back to and to check your reproducibility, and then, can you prove that you're doing better than you did yesterday? And so both the sort of a reproducibility tool and a model debugging tool really agree with Navdeep on this idea of simple benchmarks to compare your system to. Dan is showing the report, and so this is what we're talking about. Please download it if this has been interesting, and reach out if you have feedback, because we're just three practitioners kind of trying to do the right thing here, and so Ben, I think this is something you said, but it could have been Navdeep. There's an audience comment about, do you have the ability to pivot and make good on your ML system? And can you expand on that? So that sounds like a Ben comment to me, but I'm not 100% sure.
Yeah, I think that's probably poking at something I said earlier. If you have machine learning systems in production right now, I would look at sort of leading explainability methods, kind of the ones that we built in, and do like a point-in-time check, right? Can you run a disparate impact analysis and see if your customers are getting disparately treated, right? First as first. Second, can you run things like Shapley values, surrogate decision trees, partial dependency plots, and see if your features actually truly make sense, right? And if you're finding that something that you have in production right now doesn't kind of pass the sniff test on all this stuff, yeah, you should stop, you should pivot, you should retrain, and you should kind of get back to the drawing board. I think, I'm sort of an economics guy, and it's hard because a lot of machine learning, like the problems start before you even click predict, right? And it is always good to kind of take a step back, take stock about how you even went about this problem that you were deciding to solve. And if you flipped it on its head, would it just be better? I think companies who are using machine learning in production in a way that would affect customers, engage with customers, or have second degree network effects of, like, if you deny somebody of a loan, what does that mean for that person's family, right? So it matters to more than just the end customer in a lot of high stakes real situations. So you should always be continually taking stock of, is disparate impact kind of trending in a way that's not good for us? Or are certain features becoming more important, and that's kind of dubious? And then if that's true, if it's kind of sending you signals that it's going awry or finding predictiveness or trying to reverse engineer protected classes, then yes, you should pivot your models pretty immediately. And to be honest, it's not that hard, right? It's just rerunning the exercise or building infrastructure that can continually do champion challenger and see which has the highest average fairness, right? Or the most understandable Shapley values, or is the most simple, right? So you should always be looking to try to pivot and improve. And that's just one of those things, right? Like, I think data science, we got super excited and said, a model's good, let's leave it be. We should always be testing our software. Right?
Yeah, it's like the CI/CD approach to machine learning. And to be clear, I think if we're really going to do CI, continuous integration, continuous development, which is sort of the contemporary software building approach, it's going to be harder for machine learning, because machine learning is just more complex software with more things that can go wrong. Did you want to chime in there, Ben, or Navdeep?
Yeah, I was going to say, but that's, again, kind of something I called out earlier. By doing these exercises where you continually are checking these features, in explainability or fairness or interpretability, you're getting, metadata from from the models that take in all of the data for your customers, right? So if you discover that, the kind of the Shapley value feature importance changed, or we're getting a little less fair, even if it's not like a super red flag situation, you're getting real-time understanding of how the texture of your data and behavior and model predictions are changing. And that's super, super important, right? It's like when digital banking started giving all, it used to just be transactional insight, but then they started to get click-through rates, how long did they stay on certain pages, what did they respond to, and that's what you can kind of think about. That's what I like to think about for, explainability and interpretability in machine learning, because you're getting these like under the hood secondary statistics that can tell you a lot of insight about your customers and what they're doing, right?
Yeah. All right, we've got at least two really good audience questions. So the first one was, what's unique in embedding ML in real life applications and what to consider. I'll give my take on that. I think there's a lot to consider, right? And that's kind of why we wrote this roughly 70-page report. There's the people, processes, and tech to consider, right? And so, just from a tech perspective, I think that if you're making decisions in real life, you want them to be appealable and overridable. That would be one of the first things that comes to mind, right? Like, you may have heard of this A-levels fiasco in the UK, where students' grades were adjusted by an algorithm with no sort of way for them to appeal. And in my opinion, that model was very well documented, transparent, made by experts. And the problem was the way it was used and the way it was and the way that people couldn't appeal their decisions. There was no appeal process. So lots and lots to consider. I mean, I think the thing to do is step back and consider that you could hurt people, right? Like, and if you don't care about that, it could cost you money. Hurting people could cost you money. Those people could sue you. The regulators could come after you. That's one of the main things that I would think about. And then, bin or not beef, I don't. What jumps out to you about real life applications and what to consider?
Yeah, I guess I'll escalate the point you just made, right? I think I made a paragraph or two in the book about externality risk. And the A-level is a nice recent example, but like an old example was, the global financial crash, where we built a bunch of derivative products and didn't really do the math right. And I'm pretty sure everyone on this call had some kind of, third-degree impact of financial systems collapsing, right? So understand that it's not just, your bottom line at your company or your customer's decision to purchase or get a loan, the rate, there is that degree effect, but like, you should really, sit down and do some hard thinking about, okay, if we say yes or no to this person in whatever the use case it is, who else does that affect, right? And I think, as people, I think the science says, like, we're not really good at understanding network effects, but they're very, very real. And especially when you're talking about automating decision-making systems, you got to understand what the kind of like third-order degree wave impact of your ML system is.
Or feedback loops and error propagation. Navdeep, what jumps out to you when you're thinking about designing a machine learning situation, or machine learning system for real life, which is something you do every day?
Yeah, so to me, having a machine learning system in real life, it can affect a lot of people and have adverse effects on a lot of people from different demographic sectors and things like that. So the thing I want to bring up is what I've heard recently is that machine learning itself needs a version of the FDA. We need a regulated aspect to any type of machine learning. So if you think about it, with any type of drug that's deployed to the FDA, they look at, they have phases that they look at, they have efficacy that they look at, and then with machine learning, we have plenty of things that we look at when something is deployed. We want to look for discrimination, data privacy, security. Are you following some type of compliance? So these are the desired effects, and then for machine learning, that's the efficacy we're after. We want to make sure that this is holding. So that's what happens when you deploy machine learning in real life. It is going to affect people. It's going to almost always affect people in some degree. The severity is going to range, but regardless, you want to ensure that whatever you're deploying is fair and it's not discriminating against people.
So how can people test that? How can people test that their system is fair?
I mean, they can do, right now you could do disparate impact analysis looking at, across different demographics. I mean, I don't think it's too straightforward because what usually ends up happening is you can find there's not much discrimination in one group, but there is in another, or you try to decrease for one group and then the other group pops up, or different combinations of demographics pop out. So it's not straightforward, it's rigorous. But you as a data scientist or a machine learning practitioner should not be turned off by this. This is something that you need to do. This is something that can potentially make or break your organization, make or break you, make or break your team that you're working with to build these models. I mean, you have to think about it in the sense that these models that are deployed really adversely affect people. The recovery process can take some time. And then you kind of want to make sure that, you don't put yourself in that situation. And I think this type of workflow that we're presenting I don't think it'll remedy it, 100%, but it will help a big chunk.
Yeah.
Great
points. So I want to, there's two other audience questions, and so I'll answer the easy one. Okay, so what was the name of the documentary that we mentioned? I'm assuming that's Coded Bias. Is that right, Ben? Yeah. So the documentary is Coded Bias. And then really interesting question about third parties. So before we get into this, nobody on this call is an attorney, and we're not giving legal advice, okay? But this idea of third-party liability or third-party risk is super interesting because if you work in machine learning, especially at a big company, how many different people, data sets, companies, entities are involved in making a real-world machine learning system. Like, if I had to hazard a guess, I'd say, 10 to 20 different entities are involved in making a machine learning model. And so this question of third-party risk is very, very real. I think the main thing that you can do is, not accept things as black boxes. So if someone is trying to sell you a black box machine learning project, to me that's a big red flag. Like there needs to be transparency into what they're trying to sell you or what they're trying to have you use so that you can test it and debug it yourself. So I think that's one big thing. And another big thing I would think about when dealing with third-party data sets or third-party models is what kind of accountability are they able to present to you sort of publicly? So did they follow Google Responsible AI standards? Did they follow IEEE AI fairness standards? So like if you're interacting with third parties that are trying to sell you software or data, I would try to hold their feet to the fire about proving accountability to well-known standards. The questioner brings up specifically sort of these large NLP models that you can download off the internet. Those could contain Trojans. They can be discriminatory. I mean, I'm not saying like a lot of people in the scientific community use these things, so I think they're pretty well known. But it's not impossible that they could contain things that you don't know are there. And so you need to think about security scans for third-party machine learning artifacts. And then also a lot of the NLP models are just discriminatory, and how to test them and fix them is unknown. Like like Navdeep said, we have a hard enough time testing binary classifiers and simple regression models for discrimination. How to test something like GPT-3, the paper that introduces GPT-3 talks about how it's discriminatory. How to work with something like that without being discriminatory is a very difficult question. There is research into debiasing word embeddings, but I'm going to shut up and let Navdeep and Ben chime in real quick if they had any ideas on the third-party risk.
Yeah, I mean, I guess my last piece of 2 cents, and Navdeep kind of teed this up, it's just embrace the rigor here, right? Like if someone's trying to sell you snake oil that, oh, it's AI, but it's super simple, just, be honest with yourself. We know that this area is so complex, and that's why I think a lot of us have fallen into it because we love the challenge. But really embrace the rigor of this. Get into the heady problems of like, where is the data sourced? How did you design the experiment? Was the problem statement valid? Can I reproduce it? Can I stress test it? Can I trick it? Because that's what separates the the fake data scientists from the real data scientists to really embrace the rigor of the science behind this, and just, you know, don't undersell what's in the, that's it.
Okay, yeah. So I'll close by saying use the scientific method. All right, and I think we're at the top of the hour, so we better shut up. But thanks everybody, and I'll turn it back over to Patrick Moran.
Yes, thank you everyone. Thank you to all of our speakers for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us today as well. And the presentation slides and the recording will be made available on our Bright Talk channel. Please go download our Responsible Machine Learning book, and we hope you have a great rest of your day.
Thanks, everybody.